All right, everyone. So this is going to be as quick as we can make it, a simple example of how we can use the Android sensor framework to build applications that leverage the built-in sensors of a physical device. So we want to start by getting a reference to a few objects or references to a few objects. The first, and when it'll start us out, is the sensor manager. So we're going to access the system service. And as is always the case, when we're accessing a system service, we use the manager to as a handle. And we're going to use two associated classes. So we're going to have a sensor, and the example I'm going to use here is going to look for and utilize a light sensor that I believe is on the physical device I have. So I'm just going to call this light sensor. And we'll see if I just make select. I need to all really be late in its. And this is going to be of type sensor. And then I'm going to use a callback. Basically a listener that will receive information from the sensors when available. So the idea here is that these three classes will more or less work in tandem. There's one class that I have not defined, but I will be working with as well, called the sensor event class. That will be handed to me via the sensor event listener once I've registered via the sensor manager to receive input from this sensor. Initializing these objects take a relatively straightforward form. We receive a sensor manager by calling get system service and passing in the type safe reference to the sensor manager class. Once we have the sensor manager, we can now get access to a specific sensor. Now, as is always the case with Android, there is no guarantee that any sensor is available, and you really should verify that the sensor is available, or alternatively, you can get an enumerated list of all the sensors a specific device has. Now, the utility of such a feature is probably limited to the utility of to building a utility that is just going to grant access to all sensors. But in practice, you probably are looking for one or two sensors specifically, and you can just verify whether those are available or not. So in our case, we want the light sensor. So we will ask the sensor manager to get the default sensor for a specific type. The type we want, we can access via this. The reference is defined in the sensor class, and we're looking for type light. So type light is going to give us the sensor that we are looking for. Here, it's basically saying that the sensor may not be available. So it tells us that this is a nullable reference. I don't want to insist. I've not checked, so I don't want to insist. So I'm just going to, instead of making this late init, I'll make this nullable. These should have all been private, but water under the bridge. So we'll make this nullable. And then from here onwards, whenever we're going to utilize the light sensor, we'll just verify whether it's null or not. And then the last thing we're going to do is we're going to define a sensor event listener. This is going to be an anonymous object. And for this object, we're going to have two functions. One we care about a lot, one not so much. So on accuracy changed is, as the name suggests, a callback that gets invoked if the accuracy available of the accuracy of the sensor were to change dynamically. On sensor changed, however, is the function that we tend to focus on. That's the callback that gets invoked whenever new sensor information is available to us. And here you can see that this sensor event object is passed in. This is the sensor. This is the data that came from the sensor that we've registered to receive information on. And based on the type of sensor that is P0, we would be able to manipulate the data in some way. So my intention is to register to receive feedback for a single sensor, but it's possible I might have done this for multiple. If that were the case, I may want to check which sensor is P0 is referencing. So I can take the sensor from P0 and I can check the type against the various types that exist. So is it a sensor.type type light, for example? This is telling me that, okay, it's the light sensor. These are all nullable, so I should do it like this. So if it's the correct, if it's the sensor, if it's the light sensor, then I can do something. So in this case, I'm not going to do much. I just want to show that I can access the data right now. So I'll just do a debug. And I'll take from P0, I will get the values, which is a float array. So the value that I can access from P0 will depend entirely on the type of sensor. The light sensor is going to have a lux value defined inside this float array at index 0 because light only comes in as a single value. If I were to have been using, let's say, the accelerometer, then this float array would have values at indexes or indices 0, 1, and 2, giving me values for force along the x, y, and z axes. So the sensor that I'm accessing or getting feedback from will determine what type of information I can expect to receive from the float array. And this is, again, raw data that I would be expected to process in some way. But right now, all we want to do is test. So I've defined my callback, and the next step for me is to register to receive updates. As is always the case, when we register to receive updates, we want to ask ourselves certain questions, such as, when am I interested in receiving updates? If it is the case that I want updates when my activity is in the foreground, then I would register to receive updates on resume. If I want to get updates as long as the activity is running or has been created, then I would put it inside. I'd register to receive updates inside on create. Regardless of where you do that, however, you need to make sure that you do the reverse and you unregister for updates in the mirror function. So if we register for updates in on resume, we need to unregister in on pause. If we register for updates in on create, we need to unregister in on destroy. And if we used on start, we would then unregister in on stop. So in my case, just for simplicity, I'm going to register to receive updates in my on resume. And from here, what I'll do is I will take the sensor manager and I will register listener. And register listener there are a few different versions here. The one I'm going to use is one that takes the event listener. So we call that sensor event listener. The second argument is the sensor. So that for us is the light sensor. And the third argument we're going to, third and final argument we're going to pass in is the report latency. Basically, how frequently do we want to receive updates? There are a set of predefined values that we can use. They're available to us via the sensor manager. And those values basically speak to intermittent receiving signals intermittently based on the usage. So we have values like fastest, which is just give me data as soon as it's available. Game, which would give me data based on some, I guess the frequency that would be necessary for some sort of game that involves some sort of user interaction. Normal, and UI, which is, I gather, we had actually looked this up once, but if memory serves, UI, I don't have the documentation here, but if memory serves, the UI, I believe, it should have to do with the screen update rate, but I don't recall exactly. So we'd have to double check the documentation. But UI, I mean, fastest is the fastest. We would just basically get data being dumped at us at a high rate of speed. And I believe UI is probably the slowest. And I was hoping to, okay, good. So let's, should now be able to get an update. Oh, well, once it's finished indexing, we should be able to see the documentation for that. So here we can see rate suitable for screen orientation changes. Oh, that's normal. Okay. Delay UI rate suitable for user interface. And that's not really helping much. Okay, so I guess I probably read more details somewhere else. While we're here, I think what's very interesting about this particular class are the references that it provides for us. As you can see, there are a lot of different values that are predefined. For example, we're working with the light sensor, and one of the things we're going to come across is, well, how much light can we expect from a particular source, or what does a certain amount of light indicate? And while certainly this is not going to be exhaustive, it is illuminating, if you excuse the pun. We can see that they have some predefined values for certain amount of light. So sunlight max, for example, is going to give us 120,000 lux. Light in the shade is 20,000 lux. At sunrise, 400. And light outside with no moon is 0.001 lux. So we can use these as references if we would find them useful. Clearly, I would want to verify that these are correct. They seem relatively static. Doesn't seem like the kind of thing that would change in the order of or would need a large amount of time to pass before these values would be different. But still, and for these, there are other references that we can use for different things. So, for example, if you're dealing with the gravity, you can actually get the amount of gravity on Earth, 9.8 meters per second. On the moon, it's 1.6. Saturn, it's 8.96. The Death Star is whatever this is, and the island, I believe this is a lost reference, has that value. So if these were things that you could use or would find useful, then they're available to you here. All right, let's get back to this. So I've registered to receive updates, and because I did that in onResume, then in my onPause, I need to make sure that I stop. So I just do this in reverse. On register, and I pass in the sensor event listener, and that's it. So this is sufficient at this point for me to run my application. So I'm going to run my app real quick. And Just make sure that you can see everything that's on my screen. There. So everything just got adjusted a little bit. And trying to run the emulator and having some challenges. Here we go. All right, so now what we would do is we're printing our data to the log. So what I can do is hop over to my logcat, and as at this moment there is nothing happening. I'm not seeing anything because there is no light data coming in. Well, here we actually have a 0.0. But I can actually, using the emulator, I can actually emulate some data by going to the extended controls for the emulator. And once that's available to us, we can go to the virtual sensors screen. And under additional sensors here, we can see all the sensor values that we're able to modify in the emulator. And here we see the light or the lux value. It's currently set to 0, and that's what we're seeing here. And if I were to say move this value and have the emulator start again, here we can see the lux values changing. Changing, but not scrolling. So let me clear all of that and see if we can get it to actually just scroll along. So this again is sort of fake. Now, because we can go up to 40,000, all the way down to 0. And this is supposedly data being sent to my my application, being sent to my device, and then being handed over to my application to process. And right now, all I'm processing it, the only way I'm processing it is dumping it to the log. Now, this, regardless of what application you would use this for example, what if I wanted to use the amount of light to make a dynamic determination of if I want to switch my application to, say, dark mode versus light mode, where if there's a lot of light coming in, I might want to make my screen bright, all the text bright and highlighted to make it easy to read. But as it gets darker, I might want to use more shades of gray in my application so that it's not blinding to the user. Regardless of how I'm using it, whatever the application is, ultimately, I will always want to test my application in the real world whenever you are dealing with sensors. It is not sufficient to just say, well, I have my application is responding. You need to actually have a sense of what the environment is like and how much light, in this case, is being received when my device is out in a room, when it's outside, when it's under an awning or an umbrella. These are the different types of environments you want to test in, and verify how much information, what the data is that's coming into your application via the sensor, and then learning how to treat with it based on that. So what I'm going to do here is I'm going to run this application on another device. I have a Google Pixel 6a that I can show you via the screen, but in this scenario, I think it's best to show it to you in person, as in some respects. So this is a physical device. Nobody's going to promise that this is going to look good. I can't even get it centered in the camera. And what I'll do here is make sure that my logcat is displaying the Pixel 6a. And you can see that based on the environment of this device, we're getting a certain value. So I'm sitting in a home office. I have a desk light close to me right now, which is off. I'm going to turn it on. And we can see that had an effect, a slight increase in the light available. So the desk light is off and the desk light is now on. Here I have a flashlight, just a mini flashlight. I'm showing it to you. And I'm going to now turn this flashlight on and point it at the screen, close enough to the sensor. This is a very weak flashlight. I don't remember what the lumens value is, but by bringing it close enough to my phone screen where I believe the sensor is located, probably somewhere at the top, I'm getting an increase in the lux value. Turning all the lights off, and we're back, and where there's only now a ceiling light, and we get a different value. We're back down to 91. And we could, of course, keep testing by turning off all the lights, see what that value is, etc. But this is part and parcel how we build applications using sensors. Basically, we grab a reference to the sensor manager. We grab a reference to the specific sensor or sensors that we want to use. We then define an event listener in most cases because we want to register to receive updates, and the event listener allows us to process the data that we receive. We register and then unregister our listener, and then the on-sensor changed callback of the listener will be invoked every time sensor data is available to us. And you can see that we're able to specify how frequently we would like a data to be provided. If we were following the use case that I was just describing about changing the artifacts on my screen, then sensor delay UI would probably be sufficient. If I were doing some scientific measurements, then maybe I would want to go with fastest to pull in as much light data as I can, as quickly as I can. Regardless, I would then simply process it here. Now, there are rules or guidelines or best practices as it relates to processing code inside of the on-sensor changed. Specifically, you're asked not to do a lot of work here. That doesn't mean you cannot do a lot of work with sensor data. It just means you need to take the data and offload it. So whether that's copying out values from the float array here and then sending it off to a worker thread to process so that you're not blocking anything when more data is available to you, or you're not having the values here being overridden by new data being provided. So that's the basics of utilizing sensor data. We'll continue to work with sensor data over a few more lectures as we look at different features and components in the Android framework.